This is video 3 in the Bootcamp for STEM classes that'll basically help you prepare for chemistry, physics, and biology. Today what we're going to talk about is actually performing conversions. Before you proceed, once again, go get your writing utensil, paper, and calculator so you can work along. And I just want to remind you again, as I talked about in the first video, there's a difference between a conversion and a formula. And the way to identify it is really to look at the dimensions. In this first example, I'm converting distance, millimeters, to distance, which is meters. So that truly is a conversion. I'm keeping the same dimension. I'm just changing the size of that dimension. Second example, I basically am converting mass into acceleration. I'm also given force. So I'm actually changing dimensions. So that's going to require some understanding, whether it's a formula that's from science or some scientific principle that will relate those two quantities. Today, what I want to really focus on is conversions. So here's an example where I'm actually going to do a conversion. How many millimeters in 4.5 meters? And the approach I usually take is I need to think about what I'm starting with, where I'm ending up, realize they're both length conversions. So I know I need to find the connections to get from 1 to 2. And I know from the last video that it's just a metric conversion. There's 10 to the 3 millimeters per every meter. So when I set these problems up, what I like to do is start with where do I want to end up. I might even make a note to myself. Okay, I want to end up in millimeters. Then I put in where I'm starting. What is it that I'm given? 4.5 meters. And now I just put in my conversion factor. And these are based on dimensional analysis. And I'll explain what I mean when I say dimensional analysis. If I put in this conversion factor in the correct way, the dimensions should cancel. And when that happens, I can simply walk over and do the calculation. 4.5 times 10 to the third millimeters. There's my answer. And just a reminder on canceling. What do I mean canceling? How am I canceling units? If I took 8 times the fraction 1/8, or 8 divided by 8 means the same thing, it would really equal 1. So when I say I'm canceling, I'm really changing those two numbers into the number 1. So down here where I'm actually saying I'm canceling meters and meters, I'm really converting them to 1. So 3 divided by 3, or 3 times 1/3, that'll also go to 1. Even if I had an unknown, a variable, that's how I'm describing my units. If they're the same, I divide m by m, I still get 1. And that's what I mean when I say I'm canceling to 1. So conversion factors, those ratios like I just used, where do they come from? Well, we've already worked on metric conversions, so we know a lot of those, like there's 10 to the third mils in every liter, 10 to the second centigrams per gram. Time conversions, we know there's 60 seconds in a minute, 60 minutes an hour, that sort of thing. And sometimes as we start to put conversions into factors, a lot of times you save the step of putting in a 1, 60 seconds per 1 minute. That 1 is always assumed. English to metric and vice versa. You may know some of these, but if not, they're easy enough to look up. 2.54 centimeters per 1 inch, 3.79 liters per gallon. And then sometimes there's some conversion factors that we'll get once we understand some of the formulas and science principles. And these will come as we go into the class. For example, there's 1 gram per mil in water once we understand density. Or there's 18 grams per mole of water once we understand what a mole is from chemistry. But there is one conversion factor that's unique to the metric system, and that is there's 1 mil in every cubic centimeter. And I'll explain that specifically later. Another thing about conversion factors, flip them and they're still true. So 10 to the third mils for every liter, or 1,000 mils per liter. It's still true if there's 1 liter and 10 to the third mils. It doesn't matter which way I put it, it's still true. 1 minute per 60 seconds, there's 60 seconds in 1 minute. And you'll see why you need to flip that later. I just want you to think about it, whether it's true or not, and that's usually what guides your mathematics. There's 2.5 centimeters per inch and 1 inch for every 2.5 centimeters. All right, let's start doing some more conversions, and we're going to really work through a one-step conversion. How many mils are in 5 liters? All right, so once again, what do I have? I have 5 liters. I get my conversion factor, which is 10 to the third mils per liter. I stack it in such a way that the liters part is going to cancel, as we talked about earlier, and I'm going to be left with mils, which is what I'm looking for. Fairly straightforward, 5 times 10 to the third mils. How many kiloliters are in 6 liters? Same sort of setup. Here's what I'm starting with. Here's my conversion factor. Make sure that these set up in such a way that the liters cancel. 6 times 10 to the minus 3 kiloliters. I just want to remind you of why that showed up, 10 to the minus 3. Okay, so if you're basically looking at this fraction, 1 kiloliter, 10 to the third, remember that anything raised to the power of 0 is 1. And if I have an exponent, 10 to the 0 over 10 to the third, what we learned in one of the first videos is a shortcut for doing exponent math is drop one order of operations. So these are divided, so you subtract, so it's 10 to the minus third. So next problem, how many inches are in 7.5 centimeters? Start with 7.5 centimeters, find your conversion factor. You look at the dimensions, only in this case they don't cancel, so this is just a reminder. It's okay to flip these, right? So that the dimensions cancel. That's why we call this dimensional analysis. And if that's set up correctly, it says, okay, take 7.5 divided by 2.54. You get 2.95, and the units are inches. And those cancel and go to 1. How many minutes are 12 hours? 12 hours times 60 minutes per hour, units cancel. 720 minutes. That's a one-step conversion. Okay, what about two-step conversions? How many kilograms are in 450 centigrams? So one thing you might do is just kind of put a map off to the side. What are you trying to do? I'm trying to get centigrams to grams because I know that relationship from the metric system. So usually you go prefix unit to a standard unit and then standard unit back out. I can get grams to kilograms, so it's a two-step conversion. So what am I trying to find? Here's just a reminder to myself so I don't get lost. Starting with 450 centigrams, and I rewrote that in scientific notation. You don't have to. All right, I'm going to put just the dimensions just so I know that I'm doing this correct. Centigrams would cancel. Grams would cancel. I'm left with kilograms. That's what I'm looking for. Everything's great. Now let's just put in the proper numbers. There's 10 to the 2 centigrams per gram and 10 to the 3 grams per kilogram. Now these would cancel the way they're supposed to. The grams would cancel the way they're supposed to. And the math says 4.5 times 10 to the 2 minus, because this is a denominator, 2, minus 3, because it's a denominator. And remind you once again, with exponents, when you're dividing, the way you do the math quickly is you drop one order of operations. So dividing, you drop one order of operation, you subtract. So you can do this fairly quick. 4.5 times 10 to the, that's 2 minus 2, which is 0 minus 3, it's negative 3. And the units are what remains. It's a two-step conversion. What about a three-step conversion? So once again, I kind of draw out a map. I know I'm at kilometers. I want to get to meters. Meters will get me back out to centimeters. And centimeters could get me to inches if I know that metric to English conversion. And the reason I keep saying that is because I know at this point you should have memorized your metric conversions. If not, please go back to video 2 and work on those. So we're going to find inches. I'm just reminding myself. What am I starting with? 254 kilometers. Okay, I know I can get from meters to kilometers, centimeters to meters. If I look at where I'm at, I should now be in centimeters and inches to centimeters. So when I'm done, I can look just by dimensional analysis and see that I get to the right units. Now I just have to put in the right numbers. Then I can do the math. And I did this on purpose so that it'd come out fairly easy. It's 254 by 2.54 is 100, right? Going to just check that my dimensions cancel. And then as far as the exponents, it's 10 to the third times 10 to the second. Just add those up. So the answer is 100 times 10 to the fifth, and the units left over are inches. And if I wanted to write that in conventional units, remember once again, anytime I move the decimal twice smaller, I have to expand this by twice to make it larger, and then it'll be the same number. So that's 1 times 10 to the 7 inches. These are the same number, expressed differently. This is kind of the conventional way with one integer to the left of the decimal point. What about powered units? There are 3.28 feet in a meter. How many square feet are in 895 square meters? So don't just dive into these without thinking about what the dimensions are saying. How many square feet? That's area. That's like a surface that you're painting. Okay? But we do know the length conversion, so I can use length conversions to help me do area and also volume conversions, and I'll show you that next. But let's start with this. So here we go. So starting with what do I want to find? So I'm looking for square feet, and just stop and think about this. That's an area. That's a surface. Okay, what am I given? 895 square meters. So I know that I can use feet to meters as my conversion. If I put that in there once, the dimensions will tell me I should be able to cancel one of these, but I'll be left with meter feet. So how do I get rid of that second meter foot? The power of the dimension guides you to the number of times you use the conversion factor. So if the dimension has a power of 2, then you should use the conversion twice. Once I do that calculation twice on the calculator, I could just enter it. 895 times 3.28 times 3.28. Or if I wanted, I could go 895.3.28 squared. Anyway, as an answer, I get 9,629 square feet. Okay, so now we're going to try this again with the powered unit. This is a volume conversion. Dimension, and the fact that it's cubed, that should tell me how many times I need to use my conversion factor. So we start off, we're going to find cubic centimeters. And you may not, as you go along, keep doing this step. I just do it to keep track of where I'm at. I'm starting with 22 cubic meters. My conversion factor is, this is the metric system, so I know how many centimeters are in a meter. There's 100 or 10 squared centimeters in a meter. I need to do it 3 times. And now all I have to do is go back through and do the math. It's 22 times 10 to the 2 times 10 to the 2 times 10 to the 2. Remember, when you're multiplying, you should just add those. Look how I canceled out my dimensions now. So that should be 22 times 10 to the 6 cubic centimeters. Now here's another option for doing this. You might want to just bracket that conversion and cube it. And then that cube will extend to both the units and it will extend to the number. And we know on our shortcut that if I take a power and I cube it, I drop one order of operations and actually multiply. So it's 2 times 3. And that makes it fairly easy too. And a lot quicker, and kind of cleans up this mess from having to do the conversion factor multiple times. I would recommend it doing both ways a little bit at first till you get comfortable with one way or the other. Okay, what if you have numerator and denominator and you have to convert both? So here's what we've got. I've got 5 grams per milliliter. As you go on in chemistry, you'll learn this is a density. It's mass distributed over some space, okay? And I'm going to convert it to centigrams per liter. So if I think about my scheme ahead of time, I have to turn grams to centigrams, and I also have to turn milliliters to liters. Or here's where I want to end up, just to remind myself. Here's where I'm starting, 5 grams per mil. I put in that first conversion that I talked about. There's 10 to the 2 centigrams per gram, or 100 centigrams per gram. Then I put in my 10 to the 3 mils per liter. I check my dimensions. I analyze my dimensions. Do they do they cancel out the way I think and leave behind the ones I'm looking for? Yes, they do. So now my math will be correct. And once again, I've got powers that are being multiplied, so I just add them. So our answer is 5 times 10 to the 5th centigrams per liter. Now cubic length to volume. What the what? All right, so we're going to convert, use length times length times length to describe volume. So let's think about what this means, and there's something unique about the metric system. If I took a box and it was 1 centimeter wide, and it's 1 centimeter high, and it's 1 centimeter deep. Okay, so here's this, really a cubic centimeter. In the metric system, if I was to fill that with volume, exactly 1 mil of fluid would occupy that volume. And so this is a standard conversion factor of the metrics that's unique to the metric system, and length, cubic centimeters to mils, or cubic length to volume. So whenever you have to make that connection, always go back out to cubic centimeters or mils to get from one side to the other. All right, so let's continue our problem. You're starting with 6.7 cubic centimeters. So it's already in the magic unit here. So we can use our newly found conversion factor, plug that in such a way that the units cancel, and you basically have 6.7 milliliters. So now let's try it again with something a little more complicated. So now here I have a cubic length again, and I'm trying to turn it to volume, which it is a volume, but these are little different units. So once again, what I want to do is I want to make sure I get it to the magic units, which is cubic centimeters, and then I can use that cubic centimeter to mil conversion, and then get milliliters and turn it back to liters. So here's where I'm starting. 280 cubic meters. I use my first conversion factor. Once again, I have an issue because that's a cubed unit, and this is only a one-dimensional unit. So remember how we fix that? We cube up the whole thing. So now we basically have canceled out our cubic meters. That applies to both the meters and the centimeters. And now if I have cubic centimeters, I can turn it into mils with this conversion factor. And the last one is how many milliliters are in a liter, which is 10 to the third, or 1,000. And if I work this out, I'm basically going to take, now I'm not so focused on the dimensions, because if I look through there, those will all cancel. That'll be cubic meters is gone, cubic centimeters is gone, milliliters is gone. I'm left with liters. And when I say they're gone, they've gone to 1. Okay? But I just focus on the numbers. 280 times 10 squared, which you raise to the third power, is just multiplied by 3. That's where that comes in. And then this is on the bottom. It's a denominator, so I subtract 3 instead of dividing by 3, right? Remember with exponents. So I can quickly jump up and calculate that's 280 times 10 to the third. Which, if, once again, I want to move my decimal over twice, then I need to power this, increase this. If this is getting smaller by a factor of 100, I need to increase this by a factor of 100. There you go, 2.8 times 10 to the 5th liters. Here's a little practice sheet for you to work on. So at this point, pause your video, get your paper and pencil out, see if you can solve all these problems, and when you're done, restart the video and check your answers. All right, so here's your answers. Working on the first problem, it's a one-step conversion, pretty straightforward. Second problem, it's a two-step conversion. I went from centigrams out to the standard unit, the gram, from the standard unit back to milligrams, a two-step conversion. This is a powered unit. Okay, so whenever I do a conversion, I need to use whatever the conversion factor is according to that power 3 times. Or you could just bracket that and just cube it, either one. Here's a little top and bottom action, and the bottom is also squared, so I have to do the conversion factor twice. So grams going to kilograms, that takes care of the top, gets it where it needs to be. Square centimeters If I'm going to get it to meters squared, I have to do the conversion factor twice. And once again, when I do the math, 10 squared times 10 squared is 10 to the 4th minus 10 to the 3rd. It should be 10 to the 1. This is a pretty straightforward one if you remember the magic conversion factor here for metric system. And then the last problem has a lot of things in it. It basically has a cubed unit. So I'm going to get it to meters cubed. And then I get it from the standard unit back out to the cubed centimeter unit because I have to make that transition through that magic conversion factor there. And then my last step is I basically take it from the milliliters back out to liters. So once again, this is all set up properly so my units cancel. That's cubic millimeters and cubic meters on top, cubic meters on the bottom, cubic centimeters on the top. But when I actually do the math, and this I've kind of showed you the shortcut over here, I'm working on the number 12. That's 10 to the 9th. Only it's a minus 9th because it's on the bottom. It's a denominator. That's 10 squared to the 3rd, so it's on top, so it's to the 6th. These are actually plus each other because that's multiplication. All right? And the last number is on the bottom, so you just subtract it. So minus 9 plus 6 minus 3 should give you 10 to the minus 6. So there's your answer, 12 times 10 to the minus 6. But I did want to remind you, whenever you see this 10 to the minus 6, that's a microliter. Okay, that's a micro unit. And this is where the metric system comes in sometimes. Sometimes you don't want to even write it in scientific notation. And so the metric system, by doing a prefix, will take care of that number. So I hope this has helped you work on conversions. And in the next video, we'll basically work on formulas.